In this video, we are going to go over how to graph quadratic functions. Ugh. What's a quadratic function? Well, first and foremost, it's a function where, or just even an expression, if you call it a quadratic expression, where you have a variable raised to the second power or something squared. So here's how you spell it, quadratic function. You might see quad and think, why isn't it 4? Well, the reason why it's to the second power is quadros is a Greek word for square, 4 sides, right? So squared, x squared. Very cool. So how do we graph them and what do the graphs look like? Remember that no matter what you graph in math, one of the most important ideas is we can choose input values, have the function act on those input values, and then spit out an output value. The input values, in a lot of the cases in earlier math on up through college, will be x values, the outputs will be the y values, and then we have points, x, y coordinate pairs or ordered pairs, that we can then graph. And those graphs will show us what the visual of this function looks like. So it'll show us how the numbers work together visually. Without further ado, let's graph this. I typically choose the numbers -2 through 2. So -2, -1, 0, 1, and 2 as input choices. You choose them, they're your choice. The reason why I choose -2 through 2 is it gives us a nice symmetry on both sides of the y-axis. Let's check it out. So all I do is I just write out on this pre-made table my x value, my function where the work's going to go, and the ordered pairs we're going to get. And I just write in my inputs, -1, 0, 1, and 2. Now, if you want, you can draw lines to kind of keep your work nice and neat. I'll do dotted lines here. It can be dotted or solid. It doesn't really matter. Now, I'm going to do my work. Now, be very careful here. When we square a negative number, every bit of that number gets squared. This says square x. So y is equal to -2, and all of that is being squared. So that's -2 times -2, which is 4. Nice. Then you've got -1 squared. I'm going to flip around to this side while I'm working on it. So -1 squared goes like this. -1 times -1. Those parentheses help you to remember to always square the negative. And that's going to equal out to 1. Then we're going to do 0 squared. No parentheses because it's a positive number, but if you want to be consistent, put it in parentheses, that's fine too. And that's going to give you 0. Then we're going to square 1. That's what the function's telling us to do, right? Square whatever number we put in there. So I'll input 1 in there. And that gives us 1. 1 times 1 is 1. Huh, interesting. The same y values at 2 different x values. Very cool. That'll have graphical implications. So 2 squared. And that's going to be 2 times 2, which is 4, the same y value again. So we could have been writing out our points the whole time or just kind of do the work just to get into a groove. Either way is all good. -2 is the x value. The output was 4, so that's the point -2, 4. Nice. Then we get the input of -1, and the output was 1, so that's the point -1, 1. Then we've got the point 0 that we put in, and the output was 0, so that's the point 0, 0. We put in 1 and got out 1, so that's the point 1, 1. Almost to the fun part of graphing now. And then 2, 4. Pretty sweet. Input of 2, output of 4. So all we have left, and now that we've done the work, we've done the numerical piece, is to graph these points like we know how to see the relationship of the numbers. Visually, that is. So let's plot those points. So you've got -2, 4. So that's going to be left 2, up 4. There's point number 1. The second point, -1, 1. So that's left 1, up 1. Interesting. The next point, 0, 0. So we did all that numerical work so we could graph it out, and 0, 0 is right there. Then 1, 1. Right 1, up 1. Beautiful. And finally, the point 2, 4. Here it is, 2, 4. So over 2, up 4. Notice the symmetry on each side of the graph and how there's some curvature there. So sketch in the curve. We'll just kind of do a rough curve like this, bouncing around, a little wobbly, but it should be pretty curved. We call that I'm going to write the word right down here, parabola, or parabola, parabola. It's a U-shaped graph. That's it. Now, why does the U shape make sense? Well, let's take a little deeper look at it. We're squaring every x value. When you square a number, any real number, the result is going to be a positive number. Negative times a negative is a positive times a positive is a positive, and, well, 0 times 0 is not a positive, it's just 0. So you're either going to be 0 or greater when you square a number, a real number. And so that results in taking any negative number, and instead of having it be negative, well, it's going to be positive. And so any negative number and its opposite will have the same exact output when you square it, right? Negative 2 squared is positive 4. Positive 2 squared is positive 4. Negative 2, 4, positive 2, 4. There's that symmetry that we see there. 1 squared versus negative 1 squared. Each of them have outputs of 1. There's that symmetry there. What gives it the curvature is the fact that when you square a number, numbers are going to go up pretty quickly, right? You're multiplying a number by itself. So it's not going to go up at a nice constant rate. It's going to be curved. Rad. On a flip side of this video, I'm going to give you 2 more graphs. It's going to be a pretty lengthy video. That's if you need to see a couple other options of how to graph these things out. Can't wait to see you there, just to strengthen your graphing skills of parabolas, the type of shape for quadratic functions. Here we are on the flip side of the video where we're going to continue to graph quadratic functions of different varieties. And again, this is just an introduction of how to graph quadratic functions. So this function is y equals negative 2x squared plus 4. We just got done graphing y equals x squared. Let's see how this one differs. So similar to what we did in the last problem, we picked negative 2, negative 1, 0, 1, and 2 to get nice symmetry in our graph. We're going to expect a parabola for this quadratic function. Let's do it. We input these values into here, again, being careful to use our order of operations if you're not using a calculator, and I suggest using your noggin to keep those order of operation skills strong. But remember, use parentheses when squaring the number we're plugging in for x, because you're squaring everything that x is, including the negative sign. So here we've got negative 2 times negative 2. The negative 2 is from the original problem. We're inputting in negative 2, we're squaring it, and we're adding 4. Take your time with this math. Negative 2 times itself is 4, times negative 2 is negative 8, plus 4 is negative 4. So there's your output. So my input was negative 2, my output was negative 4. So in this video, I'm going to do it a little differently. This part of the video, I'm going to be doing input and then output all together. Then we're going to plug in negative 1. Negative 2 times negative 1 squared plus 4. Again, see the parentheses. Negative 1 times itself is 1, times negative 2 is negative 2, plus 4 is positive 2. Interesting. So we had quite a jump from this value right here to, that value right there. Very, very interesting. So that's going to be negative 1, comma 2. Awesome stuff. Now, 0. We plug in 0. That's going to be negative 2 times 0 squared plus 4. Just plugging it in. 0 squared is 0 times negative 2 is 0 plus 4 is 4. And so now what we have as a result is the point 0, 4. And from here we're going to plug in 1 and we're going to start to see some symmetry. Negative 2 times 1 squared plus 4. Well, 1 times itself is 1, times negative 2 is negative 2, plus 4 is positive 2. The same value we got there when we plugged in negative 1. It's opposite. Very interesting. The input is 1, 2. And then finally, we're going to plug in 2. So I plug in 2 into this function, negative 2 times, it's a positive 2, silly Mr. Gruden, times 2 squared plus 4. Well, 2 squared is 4. Times negative 2 is negative 8, plus 4 is negative 4, the same exact value we got here. So 2, negative 4 is our point. And all we have left to do now that we've input values and gotten outputs is graph these points. So let's fire away. Negative 2, negative 4 is the first one I'm going to put on there. So negative 2, negative 4 is down here. Bam, there's a point. The point negative 1, 2, left 1, up 2. Ooh, pretty steep graph. The point 0, 4. Well, that's going to be up here. Awesome plotting of points. You see that curvature happening. 1, 2. So that's over 1, up 2. There's that symmetry. Beautiful. Don't know why I'm singing. 2, negative 4. It's going to be right 2, down 4. And now all that is left to do is connect those points to symbolize that there's many points in between them going up and then down. So we come up pretty steep and then come down like that. Beautiful, and it is a parabola, a U-shaped curve. Notice that highest point we have right there, you'll learn down the road in a later math class, or later in this math class, is called a vertex. Very cool, and it's considered a maximum because it's the highest point. Notice the symmetry, notice the beauty of that parabola. Go rock some graphing of parabolas. You can do it. No matter what the parabola is, you can rock and roll with these problems.